Good morning. So today we're going to be reviewing again for the final. We'll be covering chapters 8 and 9. Tomorrow we'll do chapters 10 and 11. Then Monday you'll take your final exam. It's due by 11:59 Monday night. There will be no class meeting, regular class meeting on Monday. You just take your final. Anyway, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so we're going to take a look at some questions from chapter 8. And what I've done is just pulled up the chapter review. And if anyone has any specific questions, I'll deal with those. Otherwise, I'm just going to go through and look at some of the problems here. So if we look at problem number 1, it says, let f of x equal 9x plus 8 and g of a equal a squared minus 4a plus 4 all over 2. Find the function value. We're supposed to find g of 8. So basically, we're not even going to use the f of x function. So g of a equals a squared minus 4a plus 4 all over 2. And then we're going to find g of 8. So that means that we're going to put 8 in the place of a everywhere in the right side of the equation. So I get 8 squared minus 4 times 8 plus 4 all over 2. Which is 64 minus 32 plus 4 over 2, which is 68 minus 32 over 2, which is what? 36 over 2, or 18, I believe. So let's put 18 in there. And all right, let's move on to problem number 2. It says, let's see what we've got here. Find h of 2 and h of negative 2. If an answer is undefined, enter undefined. So we've got h of x equals 3 over the quantity x minus 4. We're to find h of 2 and h of negative 2. Okay. So h of 2 would be 3 over 2 minus 4, which is 3 over negative 2, or negative 3 halves. H of negative 2 would be 3 over negative 2 minus 4, which is 3 over negative 6, or negative 1 half. Okay, so we've got negative 3 halves and negative 1 half. And all right, let's take a look at problem number 3. It says graph the function. Well, the function is in slope-intercept form. So if f of x equals negative 4/5 x plus 1, that's like y equals mx plus b. So m, the slope, would be negative 4/5, and b, the y-intercept, would be 1. So again, we've got this information. The slope is negative 4/5. The y-intercept is 1. So on our graph, we're graphing a line. So we're going to click on that square and click on the one that's the line. Careful, not this one. That's a ray. This is a line segment. It's got to be the one that's the line, has the arrow on both ends. So our y-intercept is at 1, and our slope is negative 4/5. So we're going to go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. Okay, let's check our points. Yeah, looks like that should be correct. And let's go on to number 4. It says, write an equation for a linear function whose graph has the given characteristics. The slope is 1/4, and it passes through the point 8, 1. Okay. Well, we want to form y equals mx plus b. So we're going to take 1/4, which is the slope, whoops, and put it in for m. So y equals 1/4 x plus b. Then we can take this ordered pair and put 8 in for x and 1 in for y. So we get 1 equals 1/4 times 8 plus b. 1 equals 8/4, or 2 plus b. Subtract 2 from both sides, and b equals -1. So we know the slope and the y-intercept. So we've got y equals 1/4 x minus 1, but we're going to use function notation. So f of x equals 1/4 x minus 1. And so we get 1/4 x minus 1. And let's see what it says. Okay. So 1/4 x minus 1. Let's take a look at problem number 5. Write an equation for the linear function whose graph has the given characteristics. It passes through the points -2, 4 and 2, -10. And again, we want it in slope-intercept form. F of x equals mx plus b. All right. So first of all, I need to find the slope. The slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to call this point 1 and this point 2. So y sub 2 would be what? -10. Y sub 1 would be 4. X sub 2 would be 2, and x sub 1 would be -2. So I've got -10 minus 4, which is -14, over 2 minus -2, which is 2 plus 2, which is 4. That reduces down to -7/2. So the slope is -7/2. Okay, so using y equals mx plus b, I can put the slope in there. Y equals -7/2 x plus b. I now need to plug in an ordered pair with an x and a y to find what b is. I have 2 ordered pairs. I can use either one. I'll go ahead and use the first one. So x is -2 and y is 4. So 4 equals -7/2 times -2 plus b. Let's see, that would be -7 times -2 is 14 over 2 is 7 plus b. Subtract 7 and we get -3 equals b. So I've got the slope and the y-intercept. Y equals -7/2 x minus 3. Writing it as a function. F of x equals -7/2 x minus 3. Okay, let's go back and put that into WebAssign. Okay, so -7/2, and then we move over with the over arrow, minus 3. Oh, what's wrong with it? I forgot to put the x in there, didn't I? Yeah. There we go. Okay, let's take a look at problem number 6. Write an equation for a linear function whose graph has the given characteristics. It passes through the point 4, 0, and it's parallel to the graph of g of x equals negative 3/4 x minus 7. Okay. Now, parallel lines have the same slope. The slope of g of x is negative 3/4, so the slope of the new line is also going to be negative 3/4. So we know the slope of the new line and that the point 4, 0 is on the line. So using y equals mx plus b, the slope is negative 3/4, y equals negative 3/4 x plus b. Putting 4 in for x and 0 in for y, we get 0 equals negative 3/4 times 4 plus b. 0 equals negative 3 plus b. Add 3 to both sides. So b equals 3, m equals negative 3/4, y equals negative 3/4 x plus 3, f of x equals negative 3/4 x plus 3. Let's see if that comes out correctly. And so we've got negative 3/4, got to move the right arrow over there, plus 3. Oh, once again, I forgot to put the x in there. I caught it this time, though. Okay, let's take a look at number 7. Write an equation for a linear function whose graph has the given characteristics. It passes through the point 32, 0 and is perpendicular to the graph of g of x equals 4x plus 7. Okay. Perpendicular lines, their slopes are negative reciprocals of one another, or opposite reciprocals. The slope of g of x is 4. So the slope of the line that's perpendicular would be negative 1/4. The negative or opposite reciprocal, okay? So using y equals mx plus b, we'll put negative 1/4 in for the slope. Y equals negative 1/4 x plus b. We'll take our point that we're given and put x in there and y in there. 0 equals negative 1/4 times 32 plus b. 0 equals negative 32/4 plus b. 0 equals what? Negative 8 plus b. Add 8 to both sides, and b equals 8. So we know the new slope is negative 1/4. The y-intercept is 8. So y equals negative 1/4 x plus 8, or f of x equals negative 1/4 x plus 8. Let's see if I can remember to put x in this time. Okay. So negative 1/4 x plus 8. Yay, it only took me 3 tries. Okay, let's take a look at problem number 8. It says, write an equation for a linear function whose graph has the given characteristics. It's horizontal. Well, a horizontal line is going to be of the form y equals a constant. So y equals some number. Since it goes to the point 8, negative 33, the only y value is negative 33, so it's got to be y equals negative 33, or f of x equals negative 33. Okay. Let's take a look at number 9. In a proposal to some prospective clients, a housing contractor listed the following costs. Fees, permits, miscellaneous, $16,000. Construction per square foot, $80. Write a linear function that the clients could use to determine the cost of building a home having F square feet. All right, so the fees, permits, and miscellaneous, that's a one-time charge. But the construction per square foot, that's $80 per square foot, and the number of square feet is going to change. Okay, so our function C of F would be 80 times F plus 16,000. Again, the 16,000 would be the starting value, and that would appear only once. And then the changing value, the variable value, is the $80 per square foot. So it's going to be C of F equals 80 F plus 16,000. Now, one of the problems that people have had is, for instance, it's got to be a lowercase f because it's given as a lowercase f. If you use a capital F, it'll be wrong. Likewise, don't use a decimal point, use a comma, okay? In fact, let me just show you. Let's see what happens. I'm going to put in a capital F. Let's see what happens. Of course, now it'll say it's okay, and then I'll be, nope, see, it didn't like it. So let's go back. Let's put in a lowercase f. So you've got to be really careful, okay? Find the cost of building a home having 1,790 square feet. So basically, we want to find F of 1,790. Okay, to do that, we're going to take 80 times 1,790 plus 16,000. I'll go to my calculator, and I get 80 times 1,790 plus 16,000, and I get 159,200, and that's dollars. Okay, going back here, I've got 159,200. All right, let's take a look at problem number 10. It says, refer to the given graph to find each value. F of -2. So we're looking at this graph right here, and we're finding what is the y value when x is 2. X is 2 is right there. Y is 4. Okay, F of 0. When x is 0, y is 0. Oops, wrong number. 90. Let's fix that. Okay. The value of x for which f of x is 2. That's like saying y is 2. Y is 2 is right along there. So x is 1. And then the value of x for which f of x is -4 would be right there. So x is -2. All right, going on to number 11. It says, find the domain and range of the function. Okay, so whenever the graph goes to the edge, we're to assume it continues to go on. So if this is going down and over, it's going to go on over to -infinity in terms of x. And as it's going down and over, it's going to go to +infinity in terms of x. So the domain would be the set of all real numbers. Okay. The range, this goes down to negative infinity, but the highest range value, it appears to be -3. So it'd be less than or equal to -3. Okay. Let's take a look at problem number 12. Find the domain and range. So here, the domain starts at 0 and goes on to infinity. So it's going to be greater than or equal to 0. The range goes up to 0, but as this is going over, it's going down. So it'd be from negative infinity up to 0. Let's see, less than or equal to 0. That looks like that would do it. Okay. And consider the following graph. Determine whether the graph is the graph of a function. Does it pass the vertical line test? Yes, it does. If it is not, well, it is. So we're just going to say this graph is the graph of a function. And how about this? Consider the following graph. Is this a function? No, it fails the vertical line test. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. How about, let's see, -3, no, that one doesn't work. -2, no. -1, 3, no. 0, 3, and 0, -3. Ah, yes. Because that would be this point and this point. Okay. Find the solution set of the compound inequality. All right. So we've got 5/4 x plus 1/2 less than 4 and 4x plus 3 greater than 19. So we're going to go back to the whiteboard. And I'm going to take this first inequality and let's see. Let's clear the fractions by multiplying everybody on both sides by 4. So I get 4 times 5/4 x plus 4 times 1/2 less than 16. So I get 5x plus 2 less than 16. Subtract 2. 5x less than 14, divide by 5x less than 14/5. Okay. Let's see. I'm going to double check that. Copied it correctly. That's 5 plus 2, and that's 16. Okay. Now let's take the second one. Subtract 3. 4x greater than 16, divide by 4, divide by 4, x greater than 4, and this is and. So I'm going to take that and see what that looks like. X less than 14/5 and x greater than 4. And means intersection. If I graph x less than 14/5, let's see, 0. 14/5 is what? 2, a little less than 3. So 14/5 would be 2 and 4/5. So we're going to say that 14/5 is right about there. Okay. X greater than 4 would be there. But and means intersection. There is no intersection. So this is going to be no solution. All right, let's take a look at 16. It says, solve the double inequality, graph the solution set, and write it in interval notation. Okay, so we've got 0.9 less than 2x minus 0.3 less than 3.5. Okay. I'm going to multiply everybody by 10. So 10 over here and 10 inside and 10 over there. So I get 10 times 0.9 is 9. 10 times 2x minus 0.3 would be 20x minus 3. And 10 times 3.5 would be 35. Okay. I want to get x in the middle. I'm going to add 3 to all 3 parts. I'm going to divide by 20 to all 3 parts. Let's see. 12 over 20 would be 6 over 10 would be 3/5. I see that my graph has decimals. That would be what? 0.6. 38 over 20. Let's see what that is. 38 divided by 20 is 1.9. So we've got this situation. All right. So on the graph, let's see here. Okay. I'm going to use parentheses, and this is going to be at what? 0.6. So right there. And then 1.9 is right there. And then let's see, what do I want here? Draw, erase, undo. Let's see what that does. Does that give me open, closed? How do I get the line there? Let's try draw. There we go. Okay. Now, interval notation, it's going to be open. Oops. I guess I didn't want to do that. Let's undo that. I need to put the parentheses down here, sorry. So I'm going to put in a left-hand parentheses and then 0.6, comma, space, 1.9, and right-hand parentheses. Let's see what happens. Okay. Number 17. Solve the compound inequality. Let's see, how many problems have I got left here? Yeah. And I haven't even gotten to chapter 9 yet. So I think what I'm going to do, I'm going to skip some of these. And let's go down and let's take a look. Let's do absolute value to refresh our memory on that. Okay. If you need more examples, come back at my office hour this afternoon. 21, we've got 2 times the absolute value of 4x plus 1 minus 1 equals 17. So what I'm going to do here is isolate the absolute value first. So I'm going to add 1, which is going to give me that. Then I'm going to divide by 2, which is going to give me that. Okay. Now I'm ready to split it up into 2 separate equations. 4x plus 1 equals 9, or 4x plus 1 equals the opposite of 9. Solving the equation on the left, subtracting 1, 4x equals 8, divide by 4x equals 2. Solving the equation on the right, subtract 1, 4x equals negative 10, divide by 4x equals negative 5/2. Let's check our answers. If x is 2, then we'd have 2 times the absolute value of 4 times 2 plus 1 minus 1 equals 17. 4 times 2 is 8. 8 plus 1 is 9. The absolute value of 9 is 9. So we get 18 minus 1 equals 17. 17 equals 17. It checks. Okay. Now, I've run out of room there. So I'm going to go back and erase this. If you needed it, you can go back and check the video. I'm going to take negative 5 halves, 2 times the absolute value of 4 times negative 5 halves plus 1 minus 1 equals 17. 4 times negative 5 halves would be negative 10. Negative 10 plus 1 is negative 9. The absolute value of negative 9 is 9. So we get, again, 18 minus 1, or 17, equals 17. So both answers check. Okay, let's take a look at problem number 22. It says solve the absolute value. We have 2 minus x over 5 equals negative 3. Enter your answers as a comma-separated list, or answer, if an answer does not exist, write D and E. Well, an absolute value can't equal a negative number, so it does not exist. Okay, all right. I want to go down and look at a variation problem. Let's see here. Let's do number 25. For a fixed voltage, the current in an electrical circuit varies inversely as the resistance of the current. If a certain circuit has a current of 3.5 amps when the resistance is 120 ohms, find the current in the circuit when the resistance is doubled. Okay, so we've got, let's see, for a fixed voltage, the current, so we're going to let current equal C. And the resistance is going to equal R. And it says the current varies inversely as the resistance. So C equals K over R. Let's take a look at what I've got there. Recall K is the variation constant. It's often not even mentioned, but it does exist in each of the variation formulas. So the current varies inversely as the resistance. If a certain current circuit has a current of 3.5 amps, so 3.5 equals K over, when the resistance is 120, all right, that's going to allow us to determine K. So we're going to multiply both sides by 120, all right? So K equals 120 times 3.5, or 3.5, which is 420. So now we've got C equals 420 over R. It says find the current in the circuit when the resistance is doubled. So now the resistance would be what, 240? So C equals 420 over 240, and 420 divided by 240. Oops, 420 divided by 240 is 1.75 amps. So let's go back here and see what happens when we put in 1.75 amps. All righty. Okay, I know I didn't do all of them, but I want to get to Chapter 9. So let's see here. Chapter 9. Okay. And what I'm going to do here, I'm just going to share my screen and we'll go through. It says simplify the expression. Assume that the variable is unrestricted and use absolute value symbols when necessary. This is a problem that almost everybody missed, okay? So the square root of 25 is 5. The square root of x squared is x. But because they tell us that the variable is unrestricted, that means x could be positive or negative or 0. But recall, one of the primary rules is that when you take an even root, you can't get a negative answer. Therefore, we would need absolute values around, absolute value bars around the x. Okay. Here's another problem. It says simplify the expression. Assume the variable is unrestricted and use absolute value symbols when necessary. The square root of 64, h to the 4th. Well, the square root of 64 is 8. The square root of h to the 4th is h squared. We have the same lack of restrictions, which means h can be positive or negative or 0. But if h is squared, h squared cannot be a negative number. So, and that is as long as it's real. So we don't need absolute value bars here. Take a look at this one. Simplify the expression. The cube root of negative 27. If the solution is a real number, or is not a real number, right? Not real. Well, we can't take an even root of a negative number, but we can take an odd root. So the cube root of negative 27 is going to be negative 3. Okay. Here's another problem. 729 to the negative 2/3 power. Simplify the expression if possible. If the solution is not a real number, enter not real. Well, that would be the same thing as 1 over 729 to the positive 2/3 power. And that would be the same thing as 1 over 729 to the 1/3 power, and then square the results. Well, let's see. What times what times what is 729? 7 times 7 times 7, 243. How about, let's see, 10 times, oops, let's see, 10 times 10 times 10, that's 1,000. So it's bigger than 7, but smaller than 10. How about 9? 9 times 9 times 9. Oh, it's 9. Okay. So 729 to the 1/3 power is 9. And then that's squared. So we get 1 over 81. Okay. Let's see here. It says simplify the expression, the square root of 48. So we want to get everything outside the radical that we can. Well, 48 is 16 times 3. 16 is a square. So this would be the square root of 16 times 3. The square root of 16 is 4. So we get 4 square roots of 3. That's as far as we can simplify it. I know I'm going rather quickly here, but you can always come back and slow down, go over the video. I want to get through as many examples as I can here. Simplify the expression. All variables represent positive real numbers. We have the 5th root of 96, x to the 9th, over the 5th root of 3x to the 4th. Because they have the same index, we can put both of them inside the same radical. Then we can simplify. 96 over 3 is 32, and x to the, that's supposed to be a 9, x to the 9th over x to the 4th is x to the 5th. So now we've got the 5th root of 32, which is 2, the 5th root of x to the 5th, which is x. It told us that all variables represent positive real numbers. It wouldn't matter if they hadn't, because we're taking an odd root, and we can take an odd root and get a negative answer. So either way, we get 2x. Okay, let's see here. Number 8 says, find the domain of the function g of x equals the square root of x plus 12. Since we're taking an even root, the radicand, the amount inside the radical, can't be negative. So it has to be greater than or equal to 0. Solving this inequality, we get x greater than or equal to negative 12. Writing that in interval notation, we'd have a bracket saying it includes negative 12 up to infinity, with no bracket around infinity because that's not an actual endpoint. Okay, let's see here. This is number 9. It says, find the function value g of x equals the cube root of x minus 4. Do not use a calculator. If the answer is undefined, enter undefined. G of 31 would be the cube root of 31 minus 4, which is the cube root of 27, which is 3. Okay. 10 says simplify the cube root. The cube root of negative 64 would be negative 4, because negative 4 cubed is negative 64. Again, we can take an odd root of a negative number. We can't take an even root of a negative number and get a real answer. Let's see here. Simplify the cube root of negative 1728 p to the 6th q to the 3rd. Wow. What times itself is 1728? Well, I'm going to use my calculator. There's nothing that said we couldn't here. So let's see. I'm going to do the cube root. Oh, hang on here. I'm going to put my glasses on. 1728. I'm getting 12. So the cube root of negative 1728, that would be negative 12. That would be p squared, and that would be q. Since I'm taking a cube root, it doesn't matter whether the answer is positive or negative. Okay. Let's see here. What do we got here? Let's do this one. Still got about 8 minutes. Simplify the expression. 1/16 x to the 12th y to the 8th to the 3/4 power. Okay, so that's going to be 1 to the 3/4 power over 16 to the 3/4 power, x to the 12th to the 3/4 power, y to the 8th to the 3/4 power. Well, 1 to the 3/4 power, 1 cubed is 1, and the 4th root of 1 is 1. So I've got a 1. That takes care of that. Let's take a look at this. 16. Well, the 4th root of 16 is 2. So the 4th root of 16 is 2. And then cubing that, we get 8. Okay. X to the 12th to the 3/4 would be x to the 36/4, or x to the 9th. Y to the 8th to the 3/4 would be y to the 24/4, or y to the 6th. So we've got 1/8 x to the 9th over y to the 6th, or you could write what, x to the 9th over 8y to the 6th. Either way. Okay. Let's see here. Let's do this one. It says simplify the expression. The square root of 720 over the square root of 5. Since the indexes, or is it the indices, I'm not sure, are the same, this would be the square root of 720 over 5. Well, if we take 720 divided by 5, we get 144, and the square root of 144 is 12. How about this? It says simplify by combining like radicals. The square root of 125 plus the square root of 180 minus the square root of 320. So we're going to simplify each radical as much as we can. Let's see, 125 would be 25, let's see, times 5. So 5 times 5 times 5. The square root of 25 is 5, so we get 5 square roots of 5. 180, let's see. What's the biggest square in 180? Is that no, 16. Let's see, 180 would be 20 times 9, 36. 36 times 5. The square root of 36 is 6, so 6 square roots of 5. 320, let's see, that would be, is it 64? Let's see, 320 divided by 64. Yeah, so this would be the square root of 64 times 5, which is 8 square roots of 5. 5 square roots of 5 plus 6 square roots of 5 is 11 square roots of 5. Minus 8 square roots of 5 would be 3 square roots of 5. Okay, let's see here. It says solve the equation. I have the square root of 7x plus 32 equals 9. I'm going to square both sides since the radical has been isolated to start with. Subtract 32. 7x equals, let's see, 81 minus 32 is 49. Divide by 7, x equals 7. Let's check our work. The square root of 7 times 7 plus 32 equals 9. The square root of 49 plus 32 equals 9. The square root of 81 equals 9. 9 equals 9. It checks. I know I'm traveling at the speed of light here. Let's see here. Okay, this is, we've got the square root of 2x plus 5 equals 3. It says solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. All right, so we're going to isolate the radical. Well, I can already see we're in trouble because the square root can't be a negative number, but we're supposed to go ahead and come up with proposed solutions. So I'll square both sides, gives us 2x equals 4 and x equals 2. Okay, but if x is 2, we get the square root of 4 plus 5 is 3, 2 plus 5 is 3, 7 equals 3, no good. So on that last one, we're going to put x equals 2, but then we're going to say that it's extraneous because it doesn't work. What? Oh, I put it in the wrong one. I put it in 31 instead of 30. No wonder. Silly me. That's what I get for trying to hurry. Okay, let's try that one. There we go. Well, let's see if I can salvage this one by doing it correctly. So let's take a look at 31. Okay. Haste makes waste. So I've got the cube root of x plus 4 equals negative 3. So I'm going to cube both sides. So I get x plus 4 is negative 27. Then I'm going to subtract 4. So I get x equals negative 31. Okay. Now if I plug that in, I get the cube root of negative 31 plus 4 equals negative 3, which is the cube root of negative 27 equals negative 3. Negative 3 equals negative 3. So that means that the answer should be negative 31, and it is not extraneous because it works. And I've redeemed myself, hopefully. All right, so tomorrow we're going to come back and do chapter 10 and 11. Again, if people show up and have any specific problems, we'll do that. Otherwise, I'll just go through some review problems. I'll be back at 1:15 this afternoon. So there you go.